Hey everyone, welcome back to Econ Systems Vision Vitals. Grab your coffee, get comfortable, because today we're talking about facial authentication and how iToF cameras like Econ Systems Depth Vista Helix empower facial anti-spoofing. Now, the big question, and this is something I know a lot of our listeners have been curious about, is how do you make sure the face in front of that camera is actually a real living person? I've got our embedded vision expert back here with me. Welcome back.
Thanks. Good to be back.
Right. So let's start from the top. Facial authentication systems are everywhere now. What's actually driving this push toward better liveness detection?
So as facial authentication deployments scale across access control, identity verification, and border processing, the need to prevent what are called presentation attacks becomes critical. A presentation attack is basically when someone tries to fool the system using a printed photo, a replayed video on a screen, or even a 3D mask. Traditional 2D camera systems struggle with this because they're only capturing a flat image. So the shift is toward depth sensing, introducing a spatial verification layer that actually analyzes facial geometry rather than just the visual appearance.
Okay. So it's not just about what the face looks like. It's about understanding the actual shape of it.
Yes. A real face has nasal protrusion, orbital depth, cheek curvature, and surface discontinuities. Depth sensing captures all of that. And that data becomes the basis for a liveness detection algorithm to work with.
Interesting. So what are the key requirements when you're actually picking a depth camera for this kind of application?
There are 5 things biometric solution providers really evaluate. The first is high-depth accuracy at authentication distances. Most biometric terminals are working at close range, such as someone standing in front of a kiosk or a gate. You need accurate depth measurement to capture those microcontours we just talked about. Things like nasal protrusion and orbital depth. If your accuracy is off, those fine details get lost, and your liveness detection becomes unreliable.
Makes sense. And the second requirement?
Consistent performance across lighting conditions. Authentication systems don't always live in perfectly controlled environments. You've got indoor lighting, you've got low-light scenarios, high contrast scenes. Active near-infrared illumination is key here because it gives you stable depth capture independent of what the ambient lighting is doing.
So the iToF camera is essentially creating its own lighting for the depth measurement.
Right? That's a good way to think about it. Third is real-time depth output. Low latency is non-negotiable. If there's a delay in the depth stream, that introduces friction in the user interaction. The liveness detection algorithms need to operate on live, fast data.
Yeah, that would get frustrating fast. What's for?
Availability of multiple output streams. Not just a depth map, but also IR intensity data and confidence maps. Different biometric algorithms have different requirements. Some might use depth only, others might use a combination of depth and IR. Having all 3 available gives solution providers the flexibility to design their algorithms the way they need to.
So it's about giving the algorithm the richest possible set of inputs.
Exactly. And the 5th requirement is low processing overhead. On-camera depth computation reduces the CPU load on the host system.
Okay, so you're offloading work from the main processor onto the iToF camera itself. All right, so with those 5 requirements in mind, tell me about Depth Vista Helix. How does it actually address all of this?
So Depth Vista Helix is Econ Systems' 1.2 megapixel CWIToF depth camera based on the onsemi AF0130 sensor. It provides synchronized depth, IR, and confidence outputs, which are what biometric solution providers need. On the depth modes, It supports a 1.2 megapixel mode optimized for 0.2 to 2 meter capture range, which is right in the sweet spot for close-range facial capture at a terminal or kiosk. There's also a VGA mode that supports 0.5 to 6 meters, which you can configure for shorter operating ranges in high-precision use cases.
So, depending on how the terminal is set up and how far people typically stand, you can configure the right mode.
Yes. That flexibility is important because not all deployments are identical. On the illumination side, it uses 940 nanometer near-infrared illumination, which provides stable depth capture across low light and high-contrast environments. That directly addresses the lighting stability requirement.
And the output streams?
Depth Vista Helix provides synchronized depth, IR intensity, and confidence maps, so solution providers can use one or a combination of those streams depending on their algorithm design. Real-time onboard depth processing is built in. Integrated depth computation on the camera reduces the host system load, which makes it efficient to deploy in embedded biometric devices.
Right. And what about connectivity? How does it actually plug into a system?
2 options. There's a USB interface with UVC compliance, which gives you plug-and-play connectivity with both Windows and Linux systems, so integration into biometric terminals and development platforms is straightforward. And there's a GMSL variant for embedded deployments that need longer cable runs and a more industrial-grade system design.
Oh, interesting. So the USB route is great for getting up and running quickly, and GMSL is for the more demanding production setups.
Yep, absolutely.
Now, before we get to deployments, I have to ask something. You can literally see the difference between a real face and a spoof attempt in the depth data itself, right?
Yeah, that's worth talking about. When Depth Vista Helix captures a depth map of a real face, you can see all the natural 3D contours, the actual geometry of a live person. But when it captures a depth map of a presentation attack artifact, say a mannequin or a printed photo, the spatial information looks completely different. Those differences are what liveness detection algorithms use to identify anomalies and flag a spoof attempt. The depth data shows you proof of the difference.
So it's not just a yes or no signal. The camera is giving you spatial evidence.
Yes, and that's what makes it highly reliable.
Now I have to ask, where are people actually deploying this? Give me the real-world picture.
3 main integration scenarios. First up, airport and border control biometric systems, automated border control gates, immigration kiosks, passenger verification systems. These environments require highly reliable facial authentication because the stakes are high. You need to prevent identity fraud and make sure the person presenting themselves is genuinely who they claim to be, not someone holding up a photo or wearing a mask. Depth Vista Helix supports accurate facial geometry capture and depth-assisted liveness detection for that.
Yeah, that's a scenario where getting it wrong has real consequences.
Absolutely. The second is smart access control terminals, enterprise environments, and secure facilities. Depth-assisted liveness verification adds a layer of security that pure 2D facial recognition can't provide. And third is eKYC and identity verification kiosks, digital onboarding workflows where someone is remotely verifying their identity. Same principle, spatial sensing enables reliable liveness detection and user authentication.
So it spans physical access and digital onboarding. That's a pretty wide range of use cases from one camera.
That's the thing. The underlying requirement is the same across all of them. Reliable facial geometry capture and robust liveness detection. Depth Vista Helix is positioned as a depth-sensing companion module within biometric capture architectures, providing spatial data while giving you flexibility in how you design the rest of the system.
And from an OEM's perspective, someone building these systems, what does working with Econ Systems actually look like?
Econ Systems' experience in depth sensing and multi-camera design means biometric OEMs can integrate depth-assisted liveness detection into production-ready systems with reduced development effort. You've got reliable depth sensing performance optimized for biometric deployments, close range accuracy for facial capture, multiple synchronized output streams, USB plug-and-play, and flexible deployment across multiple biometric architectures.
That's the kind of thing that really matters when you're trying to bring a product to market. All right, let's bring it home. What's the big takeaway here?
Depth sensing is becoming an important component in modern biometric architectures. As organizations look for stronger protection against presentation attacks, depth cameras enhance liveness detection and improve system robustness. Depth Vista Helix is made to deliver exactly that.
Well said. Thanks for walking us through all of that genuinely fascinating stuff.
Always a good conversation.
And that's a wrap on today's episode of Vision Vitals. We got into the problem with presentation attacks in facial authentication, the 5 key sensing requirements that actually matter, and how Depth Vista Helix delivers on every one of them, across airport biometrics, access control, and eKYC. If you want to learn more about Depth Vista Helix, head over to econsystems.com for the product datasheet. And if you're looking for the right depth camera for your biometric or liveness detection system, write to Camera Solutions at e-consystems.com. Thanks for listening. We'll be back soon with the next episode of Vision Vitals. Until then, stay sharp and stay perceptive.